Welcome back to the Idle Engineers Seasonal Special with Part 2 of the Yuletide Count Up Reindeer. When we last left this project, the reindeer was built, stained, and ready for electronics. It was the electronics that took longer than anticipated, but we have some really great lessons to improve for next time. The lighting package consists of APA 102C LEDs, or dot stars, that we purchased from Adafruit. These are addressable and RGB, so they can be individually controlled and colored. Here I'm attaching the data pin in white and the clock pin in yellow. The data pin tells which LED to light and what color to use, and the clock pin tells how fast to blink. These are set to 12 MHz using the fast LED library for Arduino. With the LEDs soldered onto the board and the pins attached, I had to then solder the wire to the pins. The pins are great for using jumper wire or breadboards, but not so great in this application. I would have been better off attaching the wires directly to the breakout boards. Once the 25 LED sub-assemblies were completed, they were hot glued into the reindeer. This is the phase where not having the breakout pins on the boards would have been handy. When hot gluing the LEDs in place, we tried to keep the wires as separated as possible. After gluing in the lights, I used blank PCBs to make power headers. The data and clock wires go in sequence, but each LED has to have voltage in and ground connections. After all of this extra soldering, it would have been easier to do each LED individually and then cut wire. This would have taken more time per LED, however it would have saved overall time with less soldering and fewer points of connection. Along with voltage in and ground connections, the headers have the clock and data pins as well. Adafruit recommends placing resistors in line with the first LED and the Arduino. This can help prevent spikes in current that can let out the magic smoke. We then use hot glue to secure the headers, Arduino, and the leads into the Arduino pins. After assembly, it was time to upload some code and do some troubleshooting. With as many LEDs and connections there are in this project, doing some fine-tuning was inevitable. To begin checking the connections, I used a voltmeter to make sure that each LED was receiving the 5-volt output from the Arduino. Some of the solder bridges on the headers were not as solid as I'd like, so I used some copper wire to solidify the connections. Once power was available to each of the LEDs, I started to track down the data signal. Once again, using the voltmeter, I checked each LED to see if there's an output signal on the data line. After a process of elimination, I found 2 LEDs that were not passing along the data signal properly. I replaced these with 2 of the backups I had on hand. With the 2 new LEDs in place, it seemed everything was working perfectly. With the data line passing on the information, I could change each LED individually using the Arduino code. Despite having voltage and proper data signals, the last 2 LEDs in the chain were just not functioning. I would have replaced these as well, but I was out of spares. Everything seemed to be working fine until we moved it into the house. During the move, something was jostled. In the end, the Yuletide count-up clock will just have to be disassembled and reassembled with each LED checked as it's put back in. Sometimes these projects just take more time than you have. This reindeer will be back. Thank you for watching The Idle Engineer. Be sure to follow us on Instagram and subscribe for new videos.